Okay, hi guys. Hi, I'm Adam. I'm working for Capgemini as an architect, and I'm running a group of people that are designing and developing agents for over 3 years. And today I would like to show you how we test them. Testing of agents is something that people often don't do because they don't know how, they don't know they should, and because they don't have tests, they have huge problems. I would like to show you today how to avoid them. Okay, so let's kick off. Before AI, right, we had all those things that are on the left. So we had unit tests, regression tests, integration tests, QA departments, and so on, test evidence. And basically, when AI came, people are creating agents, and they do not employ any of those things very often. So the reasons for which those things were established, they are still valid. It's not like they disappeared when AI came, but simply because people just create agents like that without any quality assurance, they fall into many problems because it's hard. They don't know how. So let's start with the problem definition, right? Why do we even have the problem with testing of agents? Because theoretically, if we take LLM with temperature equal to 0, it's fully deterministic, right? It's always choosing the most probable next token, so it's fully deterministic. And what's the problem, though, right? There are actually two problems with this. So first of all, some agents works best if the temperature is, let's say, 0.3 or 0.5. So this is by default non-deterministic. And the biggest magic is that even if we set temperature to 0 and we move the large language model from whiteboard to the computer, it stops being deterministic. Like, how is that possible, right? Many reasons. So there are micro-optimizations. So for example, when software runs on a computer, let's say if it's a Java process, then you have just-in-time compiler or other things like this, they notice that they have a little bit more resources, so they may optimize, for example, the multiplication of two floating point numbers. So you will have differences, usually on the last digits, but you will have differences depending when you run them, right? The second one is multi-threading. So LLMs are primarily sequential creatures, but still, even then, they have at least several threads running. And of course, the order of threads is unpredictable, and of course, it causes the end output is different. But okay, let's say somebody would say, okay, let's turn off the micro-optimizations, let's force single-threaded, and we will have deterministic, right, LLM on our computer, right? With temperature 0, of course. No, because everything gets updated all the time. So LLMs are running on some technical stack, right? So you have operating system, you have GPU drivers, you have inference engine, LLM itself gets updated, and so on. So because all of this is very liquid and moving, basically you will never get anything deterministic, even if you set it to 0 and try to turn off all the configurations. But actually, that's not the biggest problem. The biggest problems are prompts. So when we think about prompts, like we use them when we chat with some AI in the browser, they are fairly static, right, and short. If we think about agentic prompts, they are completely different. Agentic prompts have some static part, let's say persona pattern or so on, but then they have placeholders from which data is fetched from code bases, documents, and so on. I would claim over 90% of the prompt from agents is liquid. And I want to show you the chaos theory applied to LLMs, meaning here is the same prompt is repeated 3 times with only typos as differences, right? So there is a typo in the word movie, and there is a typo in best, and there is like BSAT, right? And the target here for LLM is the sentiment analysis. So it varies from positive 97% to negative 57% just by typos, right? Of course, the more modern LLMs are less vulnerable to this problem, but the problem still exists. So those are typos, right? And you can imagine what happens if agents have 90% of prompts liquid, right? So my target is not to convince you it's a moving target, because it is. It's a moving target that moves at the speed of light. So perfect. So how can we test it? Yeah. So before Gen AI, testing was looking like this. Some people may hate me for this because this is oversimplified, but just to set the context, okay? I had some system, IT system, right? I run some operation, let's say create user, right? I get some output, let's say JSON, user 123 created, return 200. I copy paste this output, right? And I put it as expectation in my test. Right, I run my system every night in some build system, right? And if my output produced by my system is equal to this JSON, of course, this is oversimplified because maybe there are some timestamps we need to avoid, or maybe we need to flush the database because the IDs will be incremented. But in general, that was end-to-end testing. I have my output, it's green. I have something else, it's red. With agents, you cannot do this because you cannot have expectation, right? So game over for tests, right? This is why people don't do tests for agents, because they don't know how to replace this. So the idea how to fix it is an injection of benchmark layer between creation of the output and checking the expectations. Right? So benchmark is a function that takes the input of your agent and the output of your agent and gives you a score like in boxing game, right? Between, let's say, 1 and 10, right? And if we have numbers, we will know if it's better or it's worse or it's the same, or if it's better, how much is it better, like 10%, 20%, right? So numbers are so much better than this non-deterministic output. And this is what benchmarks are giving us. So basically, we need to create per use case benchmark. And what does it mean, use case? So I'll talk about 3 use cases roughly. So one is, for example, we take the code and we generate unit tests. That's one use case. The other one, we get some code, we create code improvements. And the other one is we get some code and we create a documentation for it. So those are use cases. So per use case, we need to have completely separate benchmarks. We run the benchmark on some hard-coded input. So for example, if my input is code, I should not point to head revision. I should always point to hard-coded revision in the past, so my input doesn't change. I calculate the benchmark as of now. Let's say I make this up. I get 6 out of 10, right? And then I put it into my integration test, but I cannot expect I will get 6, right? Because I may get like 5.95, and that will break the build. So I need to have some margin, and this margin is the amortization for the non-determinism, right? So let's say I come up with what's my rock bottom, 5.5, right? So everything above 5.5 is okay, it's green build. Everything below is red. Of course, I can have amber if it goes down. And over time, when things get better, I should increment the threshold. And that should always go up. This is our quality assurance, automated in the build. And this is how we create integration tests for the agent. Okay, it's all perfect, but we don't have a benchmark. So how can I create the benchmark? I know how to run it, how to plug it in, how to manipulate on its output. How can I create the benchmark? So first case is unit test generation, right? So we get code base, we work for a couple of hours, and we output pull request with unit test that covers this code base, right? And here I simply benefit from the fact that the output is code. So if it's code, there are plenty of third-party tools I can just run for free, and they give me numbers. So basically, that's the idea. So I run the coverage, like for Java, Jacoco, or things like that. I run the mutation testing, like PyTest. I run the sonar or check style or static code analysis. All of them give me numbers. I would like to emphasize, for example, that quality of test, meaning mutation, is twice more important for me than coverage, right? But you may have whatever numbers you want. It's just to show that this equation you can manipulate as you want. And all of that I multiply by 0 or 1. 0 if it doesn't compile, 1 if it compiles, right? Because that's often missed. So, okay, another benchmark. Code improvements. We get code, right? Agent is talking with AI to get improvement for this code. And how can we create a benchmark for this use case? Very simple. We measure sonar before improvement. We measure sonar after improvement. If there is no improvement, it's 0. The bigger improvement, the bigger score. we just need to scale it to 1 to 10 to get nice results, and that's it, right? So that was easy, mainly because the output was code. I could take a lot of third-party tools for free from internet, right? Run them, they give me numbers, I manipulate of those numbers. I have a deterministic benchmark, right? But what if I produce documentation? Oh, I cannot use Sonar, right? I cannot use mutation testing, coverage, compilation, nothing, right? Okay, what if I produce, for example, user stories from requirements? Ah, the same. What if I vibe code? Sorry, the V word is forbidden now. So spec-driven develop applications, right? How do I know that an application actually is doing exactly nothing more, nothing less than I specified in the requirements? So I will show you how we do it for documentation end-to-end with the full technical solution. So if we cannot use third-party tools and have a deterministic benchmark, we can try to have a non-deterministic benchmark, meaning we can use LLM. But wait a sec. All the target here is to get rid of the non-determinism. And we want to fight it with more non-determinism, right? It seems crazy, right? But in general, that's doable if we apply certain techniques. It reminds me the cases where in the old days when there was a fire on some oil fields, they were putting down the fire with dynamite, right? So as always in those cases, if we find this kind of similarities, it's better to be careful. So here, of course, how this could be done. You can just provide input and output, just like the benchmark before, to LLM and ask for the score. We can provide two outputs, let's say created by the older version and by the newer version, and ask which one is better, right? And of course, we can provide a description, what we would like to look at in the content, what is important for us. But still, we will have this non-determinism, right? That the LLM that will be used in those tests will not be deterministic. So we can, of course, run it multiple times and get some average. I will show you details how. And, of course, use zero temperature for the LLMs used in tests. Okay, so this LLM-based benchmark is also called LLM as a judge. And the way we did it for documentation is like we started breaking our stuff. Because it's very difficult for me to make my engine so much better, and I need some criteria, it was so much easier for me to break it. So if I break it a bit and the score goes down, and I break it even more and the score goes even more down, I know that there is a correlation between the score given by the LLM and my input. And breaking is the easiest. I get it in half a day, right? So we broke it completely, partially, both, and we had a lot of techniques how to break our stuff, just to make sure that the numbers go down or up depending on our actions. So we basically had this very simple three categories. One is completeness, correctness, and clarity. And as you notice, all of them start with 1. Why not 0? Because 0, in our case, means lack of output. And for lack of output, we don't need LLM. This is a common mistake where people, once they have LLMs in hand, they just use LLMs for everything. You don't really need LLM to assess if there is no output, right? So that's why we never ask LLM to judge it. We just find it out ourselves in a deterministic way. If we have output that we would like to judge, only then we employ LLM, and hence we always start with 1. And the agent we were testing as a LLM as a judge had documentation for every file, and then per group of files, let's say in Java there is a package, in .NET there is namespace, there was a summary. Because the file documentation are the source of the summary, we set the weights as 70% for the file level and 30% for the summaries. But this is up to the designer of the test, meaning what is more important for me. So, okay, so what we used as LLMs, I will show you two extremes. One is GPT OSS 120B. It's an open source model, which is basically like ChatGPT 5 zipped into open source model, available on the Olama library, and you need some decent hardware to run it. So, for example, we run it on NVIDIA Spark that has 128 gigs of unified VRAM. So it's generic purpose model. From OpenAI, and it's a big one, right? Now the other one is completely different. It's 7B bespoke mini check, which basically you can run on any laptop if you have GPU, right? And what are the results? Basically, between them, there were almost no differences. So the generic, very big model and the specific, very tiny model were giving us for the documentation LLM as a judge use case, but almost the same results. Even more interestingly, sometimes there were bigger differences when I ran the same LLM twice, rather than between the two LLMs. So it makes no sense to spend so much money on the hardware here if we just want to do this this way, right? Of course, for this use case, right? There may be more difficult use cases. So how do we amortize no-determinism? Okay, because we have this bespoke model which is specialized, right? It's 7B, so it's small, we can run it perfect. But how do we deal with the fact that it will give us different numbers at different moments? So the way LIBOR was calculated a couple of years ago, because I don't think they do it anymore, was something like that, that all the banks were coming up with rates and they were rejecting 25% minimum ones and the 25% the maximum ones, and they were getting the rest and making the average. And we kind of copied this approach from the finance world to amortize non-determinism in the LLM as a judge, because the odds are the hallucinations are in the extremes. But even if some hallucination goes to the middle of the Gauss, still it will be averaged, so the impact will be minimized. Okay. But when we use LLMs, and the LLMs are our judges, so they tell us if our software is good or bad, we need to be very careful, because LLMs have biases. I would like to show you 4 kinds of biases we found and what we can do with them. Some of them are trivial to fix, but we need to be aware that they exist, and some of them are quite difficult. Okay, so let's start with the first one. So the LLM prefers its own output. Right? We can call it a narcissistic LLM. This is very easy to solve because, let's say my agent is using Mistral, so I will use the bespoke model for judge. Solved. Right? Just use different LLM, bias solved. Right? And the other one is that if you provide pairs, and we often want to check if the newer version is better or worse than the previous version, right? So we provide pairs of output and ask just 0, 1, what is better or worse? It often chooses the first one. Just like, the first slide of the presentation and this kind of stuff, right? This is, again, very easy to spot because we can just switch the order of the pairs. And if it sticks to the same pair, that's good. If it switches, then it meant we need to reject it as a hallucination or bias. Okay, so the third one. Some LLMs just prefer longer answers. And what we can do with this, right? So basically 2 things. We can compress the longer to have the same size as the other one, but this is not ideal because we want to compare stuff, not compare some compression of it, right? So we will compare different things that we want. And sometimes in agents, in some cases that's not applicable, but sometimes we can require that the output will be of certain length. If agents always produce, let's say, 500 lines files, this bias will not kick you, right? Because everybody will be 500 lines, right? Okay, this is the worst. So often LLMs prefer writing quality over correctness, meaning they can accept the beautiful fairy tale, but will reject a bold list of facts. And we want to stick to the facts because obviously the biggest problem with LLMs as judges is that standard LLMs are fine-tuned to sustain conversation. So you will hear a lot like, great idea, yeah, you're, of course, perfect, yeah, let's do this, super positive, and so on. But you don't want to have this guy judging your software. You would like to have this sad guy who always tells the truth. So basically, for this bias, probably we can use LLMs to check it, but in general, I would say humans should check it before we run the whole integration tests And of course, human cannot be part of the integration test run. So we can only check it before or after. Okay, and this is kind of the picture to finish how we see it after years of developing agents. So here, basically, we started without any tests, and we were breaking our agents many times, and we were spotting this after a week or two. Then we looked like, okay, so it was broken somewhere between now and 2 weeks ago, and we have 120 changes to go through. So it was very difficult to correlate the change that broke it, especially since the agent can give you different results when you run it twice. And this was looking like the left side of the picture, right? So you have your car going through some earthquake and you will fall into the hole. Certainly it will take a long time to dig it out, right? And if you put the integration tests, if they are deterministic or not, into your pipelines as DLC and so on, it's not only that you don't have those holes, but you have the light, and it tells you in numbers if you are getting better and how. Thank you very much. I think we have time for questions, like 8 minutes. Yeah, go ahead.
Yeah, thank you for the presentation. You mentioned the task of quality assurance of the agent that wrote some documentation, for example.
Mm-hmm. Yeah.
And you mentioned that there are different types of scores, like completeness, correctness.
Yes.
And these scores are subjective, I can say.
Yeah.
More or less, yeah. And they require some additional context for the LLM. Like if we write documentation for the code, we need the code itself.
Yes.
So
yeah.
My question is, how do you provide this context for the LLM? And do you have deterministic checks as well? Like documentation requires this part specifically. And
yes. So of course we provide input and output of the agent, right? And then ask rate, correctness, clarity, and everything, right? So those things go into the prompt for, let's say, the LLM as a judge, right? The problem is that I don't have anything deterministic for documentation, because there is no tool I could run, right, that would give me numbers. So LLM is the only thing we have. But of course, at the beginning, a human is checking, and then once it's all good, then we just put it in the automated pipeline.
So don't you use human experts to just write some simple checks that the documentation should have this part, and this?
There's input and output, and basically output is a summary of input. If some things are missing, this is the LLM job to find it. And these LLMs are trained in fact-checking. They are going through some benchmarks for LLMs like agre-fact or something, right? And they get some high scores in there. So this is their target.
Okay, thank you.
There's a question there.
Hello, I've got a question about the business value of testing the agents, because nowadays many people in companies simply don't test agents and say that it's not really valuable from the business point of view. So in which cases it's like truly matters that we need to test agents?
I would say in all. Because, you know, in IT, if you don't have a test, you don't know what you have. That's my view after, 30 years in IT, yeah? It's, without tests, how do you know it's working? How do you know it's doing what it should do? Even if it does now, how do you know it will do it a minute from now with no changes? It's agent, right? So it may break a minute with no changes, nothing.
Okay, so maybe I will ask this question different way. So in which cases it is valuable to build some automated testing, like the testing which cost a time?
It's, as you see, this is not hard, right? If you just know the biases, you know what to check. This LLM as a judge is quite simple. If you know how to do this. In AI, it's not difficult. There's people, many times, they never done it, for example.
Okay,
The difficulty is to start.
Thank you for presentation, pretty decent one. I'd like to highlight one question. Let's say we have more hallucinations once we have more tokens in our context window. And so, as far as I understand, like to get more deterministic output, we'd like to split the context as much as possible. Did you try to build this rate system maybe by splitting context window, the task across, let's say, thousands of agents? Did you try such experiments?
The case with documentations is already split. So we provide one file and documentation of one file. That's the whole context window, nothing else. So it's tiny. It's a few thousand lines, maybe.
Is it correct that you mentioned that you split the text, the documentation, into parts? So each part handled by agent independently, is it correct?
So the agent creates, I mean, this is easy to make it like in parallel, right? But in general, the agent takes the file, and for each file creates documentation, and then files are grouped. It depends on the language, like in Java, you have package, namespace, and so on. So then you have a summary of this group, right? So summary is the only thing that requires bigger context, summary. Each text file is tiny and it's a separate context. So basically, conversation with LLM as a judge contains two files and the prompt saying like, you know, you are an expert, you need to judge this, this is the score.
Thank you. Thank you.
Hello, thank you for presentation. I have one question, maybe from more technical perspective. What was the first, agent or scoring for agents?
So the first agent was called Code AI, and it was generating unit tests. And we developed it over three and a half years ago. So we didn't even use the word agent. It was not a buzzword at the time. And the first benchmark was deterministic, because we didn't know how to do LLM as a judge, right? And we just ran all the tools. It was easy for us because agent runs them in runtime, right? So when agent generates, he already runs it, right? So for us, it was easy to create in the same code base the test, which is basically using something that it was already there. It was quite difficult to run mutation testing runtime because they are designed to run as a Maven build. You had to cut through some layers, right? But in general, that was a technical problem was with mutation testing.
Okay, it was included in some kind of CI pipelines?
Yes.
Yes, okay.
Yeah. So every night, it calculates this benchmark or a hard-coded not moving input. And we know if we go up or down.
Yeah, thank you.
That's it. Okay. No more questions. Thank you.